All right, guys, here we go. 16.2. So basically, we're going to talk about climate change, okay? How basically what it is, the evidence for it, the computer models, which are really, really, really big supercomputers that deal with this stuff, and basically the impact of both what we're dealing with right now, which we talked about yesterday, as well as potentially in the next couple of decades, what we're going to really be dealing with. Okay, these three words are updated on the vocab slides on my version that's attached to it. So basically, the three words you just got copy from mine into yours, like we always do. All right. So we talked about Greenland in the case study yesterday, so I'm not going to go into that details again. All right. So first off, climate change in the average weather conditions over a period of at least 3 decades. Okay. So basically 3 decades. A decade is 10 years. So 30 years is kind of the idea. All right. So basically, average weather is changing. Okay. Over Earth's 3.5 billion year history, climate has changed a whole bunch of different times. Okay. But like I've talked about also a whole bunch of different times, it's not climate changing, it's the speed of the change that's causing the issue. Okay. For the last 10,000 years, we've lived in basically a relatively steady time frame. They call it the Holocene. All right. So basically, you can see thousands of years ago, look, 900,000 years. Just look how just back and forth and back and forth and back and forth the average temperature has been. So again, climate changing isn't the problem. The speed of the change is the problem. All right. So atmospheric temperatures have risen right along with population growth. And we've talked about that a bunch of times. Population growth is the root of a lot of the environmental science problems. Okay, the rate of climate change has been accelerating since the late 70s. Okay, past climate change took thousands of years to do. So basically, nature is slow, evolution is slow. That could evolve as the climate was changing. But since we're changing the climate so fast, it's hard for nature to keep up, or almost impossible for nature to keep up. Okay, current climate change, like I said, taking place over the last couple of decades. All right, now the evidence of past and current, the past. Okay, we got isotopes in the rocks, we got fossils, we got ocean sediments. Okay, we got tiny bubbles in the ice cores. Okay, the layers of soot, other materials trapped in ice cores from glacier. We got a whole bunch of different evidence of this stuff. The pollen from the lakes, the tree rings, tons of different things. Present data. We have just thousands and thousands and thousands of monitoring sites around the world in every continent and every latitude and stuff like that. So basically, we're taking a whole bunch of satellite data and just data from anything and everything constantly. So basically, right now, we are really seeing, because basically last time, like in the past, we've looked basically fossil evidence. Now we're taking measurements constantly, constantly, constantly. All right. You can see now average temperature. I'm going to jump back real quick. Okay. Look at, where's that picture? Look at that. Okay, basically going from, you can see the bottom is probably going to be what, 48 degrees Fahrenheit, going up to 62. This is over 900,000 years, just skyrocketing back and forth and back and forth and back and forth. Okay, this one, look how it's basically going up and down and up and down, but it's slowly but surely rising. In the other graph, there wasn't any sort of trend of always getting cooler or always getting warmer. Now we are. All right. So the IPCC, the NAS, the British Royal Society, but basically all these are international science organizations. Okay, I could go through all the acronyms, but we don't really need to know all of them. Okay, all of these guys have concluded: A, climate change is happening. It's caused by us, and it's only going to get worse unless we really change our behavior. Okay, that's basically what all the legitimate scientists around the world have come to the conclusion of. Okay, now we need both immediate, so like right now, not in like, oh, the next presidential term 6 years down the line, like now. We need to start changing stuff now. Okay, and once we change it, it needs to stay consistent. Like we basically need to make the change and stick with it. Because if we make the change and then nothing happens, then that's like everybody at the New Year's gym. You know, we go to the gym for 2 or 3 or 4 weeks if we're lucky, and then we just pay the gym membership for the rest of the year. Okay. The sooner we act, the lower the risks are to everybody involved. Okay. Every country, rich person, poor person, everybody. All right. Current climate change. Okay. Right now, temperatures are rising. I think I brought it up yesterday. The last 10 months, basically March, February, January, December, so on, so on, 10 months going back, those are the hottest 10 months on record since the early 1920s. That's not good. Okay. Climate change is happening right now. All right. Last 9 years have been the hottest since global records began in 1880. Like, it's not good. Okay, glaciers and summer Arctic sea ice are shrinking. Okay, there's melting permafrost. There's rising sea levels. Okay, more atmospheric greenhouse gases. Like migration of species towards the poles. Like basically, things are moving to where it's colder because it's just getting hotter everywhere. All right, greenhouse effect. This is magnified by the Industrial Revolution, which is basically when we started burning fossil fuels. Okay, the carbon footprint that we have, okay, that's the amount of CO2 generated over a given period. So I can have a carbon footprint, you can have a carbon footprint, we can have like a Lakewood or a University Place or a Washington or a United States carbon footprint, all the different things. All right. Now, the CO2 and the heat that is absorbed by the ocean is honestly saving us. That is the big sink out, or the big sort, or excuse me, the sink of all the different CO2 and warmth that we're basically doing it. Okay. Cloud cover has both an increasing and a decreasing effect on atmospheric warming. Okay. So let's talk about the increasing. There's clouds, heat comes down, heat bounces back up, the clouds keep that heat in. Okay. So that can increase the temperature. It can decrease the temperature because basically there's cloud cover and there's sun coming in. That sun's radiation is going to hit the clouds and bounce back off into space. So that would be a decreasing effect on temperature because it's going to be both sides. All right. Now, this rapid change can have really long lasting effects because the snow and the ice and the permafrost melts. The permafrost melting, that's a real big problem. Okay. That will mean the loss of glacial water supplies. So think of most of the west coast of America is reliant on snow melt and glacial melt every year for its drinking water. If that all goes away and we aren't getting more snow, where are we going to get the water from? Okay. The permafrost loss also accelerates atmospheric warming because it actually releases methane, and methane is a real big greenhouse gas. Okay, sea level rise, we talked about that already with Greenland. There's more extreme weather events, okay, the flooding and the heat waves and the drought and so on, so on, so on. Basic idea with climate change and weather is basically whatever is occurring is going to become more extreme. So, for example, here in Washington, we obviously have the dry periods and the sunny periods, but we also have the rainy periods. So, basically, think when it would normally rain, it's just going to rain a lot more. When it's normally hot, it's going to get much hotter. That's the idea. Climate change just basically takes the norms and makes them into extremes. Okay, there's also going to be biodiversity loss as well because those things that are moving towards the pole to get to the colder weather, if there's no more colder weather, the biodiversity loss is going to start to occur and extinctions are going to start to rise. Okay, a projected 3 foot rise, not even the 23 feet we're talking about the Greenland, but only 3 feet. Okay, degradation and destruction of the coastal estuaries, the wetlands, the coral reefs, the deltas, the coastal fisheries, flooding of low-lying countries and cities. Like think of the Maldives. The Maldives currently are like legit; they are going underwater. They are actually going underwater. Okay, their highest area, I think, in the entire Maldives is 5 feet above sea level. Like that whole country is gone. Basically, okay? Saltwater invasion of coastal aquifers, and that's bad because aquifers is what gives the irrigation water to crops. Okay. This basically is showing all the different, I'm pointing at the screen like you guys can see it. All the different areas that are circled, those are the areas that are going to be affected by sea level rise with just 3 feet. Okay. Like I said, I think I said it yesterday of 23 feet, that's 65% of Florida. The red, this is only 3 feet. Like basically Miami and the Key West and all that, Key Largo and all that kind of stuff is all gone. Okay. Some regions are going to experience increased chances of extreme drought. Okay. Basically, again, the regular stuff is going to become more extreme. So the deserts are going to start to expand outwards because there's less rain at certain times. Okay. Other areas, more precipitation, stronger hurricanes. Okay. Warm ocean, like a warm Atlantic Ocean, makes the hurricanes that hit the East Coast. Warm water is basically the fuel for that stuff. All right. 85% of the Amazon rainforest could be lost and converted to tropical savanna. So basically, just there's not really many trees. It's more of like a grassland kind of area. 25% to 50% of the world's species could face extinction. Insect and fungus populations could explode. Insects carry disease. Okay, they call them vectors. Okay, if insects can basically go everywhere in the world, disease is going to basically go to a whole bunch of different more places. Okay, crop diversity is gonna happen as well. Okay, we're basically gonna start losing the different things that we have. Again, going back to if we're reliant on only a few different crops, if we lose two or three of them, that's 30, 40, 50% of our diet starting to go away. All right. Health related stuff, that obviously is going to be a problem because, like I said, insects carry diseases. Okay. Spreading of disease transmitting insects, like I was saying, economic costs of droughts and flooding. So, if all of a sudden Washington's in a drought, we need water. The government's going to need to pay for the bottled water to come from shipped from somewhere else. All right. Food and water scarcity is going to start to become an issue. There's going to become lots of poverty and social unrest. Like we talk about with water is a national security issue. This is what we're talking about right here. Okay. Migration of environmental refugees, like those in the Maldives. Their country goes underwater, so they need to move somewhere. Okay. Political instability as well. Okay. Basically, they're going to start fighting for things. All right. I know I ripped through that really fast, but it's pretty straightforward because obviously with a video, you can pause. All right. Have a good day. Make sure to check out that or work on the infographic as well as the vocab slides. Have a good one, guys. See you tomorrow.